Today in physics, electrostatic potential and capacitor. Now to see one numerical. Numerical is based on parallel plate capacitor. We know that the capacitance of the parallel plate capacitor C is equal to epsilon 0 A upon D, or we know that capacitance C is equal to Q upon V. So using this formula we have to solve this numerical. The numerical is like this way, just you can see here. A slab of material of dielectric constant K has the same area of the plate of the parallel plate capacitor, but has the thickness is 3 by 4 D, where D is the separation between the plate. How is the capacitance change when the slab is inserted between the plate? Now let E0 is equal to V0 upon D, where E0 is the electric field of free space or air, and V0 is the potential difference. Now electric is insert between the plate. The field is given by E is equal to E0 by K, where K is dielectric constant. K is dielectric constant. Now the potential that is V is equal to V0 upon 4 plus 3 upon 4 V0 upon K. Now simplifying, we will get here is equal to E0 into D upon 4 plus 3 upon 4 E0D upon K. E0D common, so we get here 1 upon 4 plus 3 upon 4K. Now E0D is the here, that is a V0. Now we will take LCM, so we can get here K plus 3 upon 4K. Now here the potential is decreases as K plus 3 upon 4K, but the free charges on plate remain same. Therefore, the increase in capacitance, that is C is equal to Q0 upon V. Keeping this value, we can get here, that is a Q0 upon V0 into K plus 3 upon 4K. Therefore C is equal to 4K upon K plus 3 into Q0 upon V0. Now we know that C0 is equal to Q0 upon V0. Keeping this value, we can get here C is equal to 4K upon K plus 3 into C0. So this way the capacitance will be changed. So this was to understand this numerical. In this numerical, here the parallel plate capacitors having a separation that is small d, the dielectric slab and parallel plate capacitor have the same cross section area. Here dielectric slab of 3 upon 4 D is inserted between the two parallel plate capacitor. We will find out the change in the capacitor. Here we know that when the parallel plate capacitor in the free space or air, that is field E0 is equal to V0 upon D, where E0 is the field at the free space or air, V0 is potential difference. Now dielectric slab is inserted, then the field E is equal to E0 by K, where K is dielectric constant. Now field here, the potential is given by, that is V is equal to V0 by 4 plus 3 upon 4 V0 by K. Here we can put, we know that here that is E0 is equal to V0 by D, therefore V0 is equal to E0 into D, keeping this value, taking common, again keeping V0, so finally we can get here V is equal to V0 in bracket, that is K plus 3 upon 4 K. Now here the potential is decreased by the amount of K plus 3 upon 4 K, and the charges on the plate, free charges on the plate remain unchanged. Therefore, the increase in the capacitors given by C is equal to Q0 upon V. Keeping the value of V and simplifying, we get here at the last C, that is C is equal to 4K upon K plus 3 into C0. So these way to understand this thing. Thank you very much. Therefore, C is equal to 4K upon K plus 3 into C0. So this way the capacitance of the parallel plate capacitor is increased. So this way to understand this. Thank you very much.